All right, so this problem says find the Norton equivalent with respect to the terminals A, B. So there's no independent source. So we know that our I Norton is going to be equal to 0. So in order to find our R Norton, we want to plug in our own source, and whether it's a current or a voltage, we have to find the equivalent, or so if it's a voltage, we want to find the current coming out of it or coming into it. I mean coming out, yeah. And if it's voltage, or if it's a current, we want to find the voltage uh, across it. So for simplicity, for just to make it simple, I'm gonna use a voltage source. I'm gonna call it 1 volt, and I'm gonna draw the loops. Right, call this one I1, which this one doesn't really matter, right? So, well, yeah. So I can say, well, first equation, we know that Ix, or yeah, Ix would be 0.5 Ix minus, I'm going to call this Is. Right? And then for our second equation, we're going to say -1 plus 750 times Ix equals 0. So we want to find Is, whether it's negative or positive, because it's, well, whether, if we know, if it comes out negative, we know the current's going in the reverse direction. Comes out positive, means the current is in the right direction. So I'm going to go ahead and plug this in. And I have two equations. So we have Ix equals 1.5 I times X minus Is, -1 plus 750 times Ix equals 0. We have Ix and Is. So our Is is 1/1500, and our Ix is equal to 1/750, right? So with Is, this is the value that matters. We're able to find our R Norton or R Thevenin, doesn't matter. We know this is V over I, and our V is 1/1500. Our Norton is 1500 ohms. So our equivalent circuit look like this. Yeah, let me just